Hello students, welcome to the unit Database Systems 2, BIT3107. This is from the School of Computing and Informatics, Department of Information Technology, and we'll be continuing. Previously you had done Database Systems 1, and in this unit we'll be looking at some more advanced concepts of databases, mainly the implementation of databases. In database 1, you did entity relationship diagrams, and today we are going to look at the enhanced entity relationship diagrams. So in this particular topic, you already know that you already have the basics of entity relationship modeling. So we'll be looking at some additional concepts, and these additional concepts are on subclasses and superclasses. We also look at specialization, we'll look at generalization, and under this we also look at attribute inheritance. So once we have factored in all these aspects here, that results into something that we are calling the enhanced entity relationship models, or the extended. And in some cases, you might find some books referring to them as ER2s or E2Rs. And our main core textbook for this one is Database Systems by Connolly and Begg. So it is used to model applications more completely and accurately if needed. And also, enhanced entity relationship diagrams include some object-oriented concepts such as inheritance. So we'll be looking at subclasses and superclasses, and we want to see what subclasses are and what superclasses are. An entity type may have additional meaningful subgroupings of its entities. And just to remind us, or just to remind you, an entity is anything real or abstract about which data can be stored. Anything real or abstract about which data can be stored. And databases store this data. So we want to see, before we even go to the subclasses and superclasses, the knowledge that you already have, you already know that real entities, we can have things like in a university setup. A university would like to store data about the students, would like to store data about the lecturers, would like to store data about the units that they are doing, would like to store data about the different classes that have taken place. All this data would be kept in a database. Abstract classes, because when we talk about a real class, or a real class in this particular, or real entity in this case, is a student. A student is physical. Student is physical. But when you talk about something like a qualification is not something that you can touch or feel. It's something abstract. When you be graduating from Mount Kenya University, you will graduate with a Bachelor of Science in Information Technology. There are also other students doing Bachelor of Business Information Technology. That is a qualification. A qualification, you cannot be able to touch a qualification because it's something that abstract. It is defined through a curriculum. It is abstract. But a student, a lecturer is a real entity, is not abstract. So, when we talk about an entity type may have additional meaningful subgroupings of its entries. Let me use an example here. An employee may be further grouped into secretary, engineer, manager, technician, salaried employee, hourly employee. All these are employees. They are employees. In our situation here as a university, we can have different types of students. We have full-time students, we have part-time students. All these are students. It's only that we are subdividing these students from the main classification, main category, which is student. They are all students, whether they are full-time students or part-time students. All of these are actually students. So each of these groupings is a subset of employee entities, going back to our example here. So each is called a subclass of employee. So what are the subclasses here in this situation? In this case, the subclasses of employee is secretary, is a type of an employee. We have engineer, is a type of an employee. Manager is a type of an employee. Each is called a subclass of employee. So in this case, we have various subclasses. We have various subclasses. We have the secretary, engineer, manager as the subclasses of employee. So employee is the superclass of each of these subclasses. So when looking at it in a general form, a secretary in our case here is an employee. An engineer is an employee. Looking at the example that I was giving previously of the student, a student, whether full-time or part-time, is a student. So employee is the superclass of each of these subclasses. So these are called superclass, subclass relationship. That is how they relate. The superclass employee with the subclasses secretary, engineer, that's the superclass, subclass relationship. So an employee can be a secretary, can be an employee, can be a technician, and so on and so forth. So these are also called is-a relationships. When you're talking about the subclass in relation to the superclass, the subclass is a type of. Look at this scenario. A secretary is an employee. A technician is an employee. A part-time student is a student. A full-time student is a student. So an entity that is a member of a subclass represents the same real-world entity as some member of the superclass. So in our case here, and maybe a secretary, in this case, a secretary is also an employee, and a secretary represents an employee of an organization. An engineer is also an employee of an organization. An entity cannot exist in the database merely by being a member of a subclass. It must also be a member of the superclass. So you cannot say that you are just a part-time student. You are just a part-time student. You don't belong to the student category. Whether you are a part-time student or a full-time student, you belong to the superclass student. A member of the superclass can be optionally included as a member of any number of its subclasses. And we are going to see this as we move forward. For example, a salaried employee who is also an engineer belongs to the two subclasses, engineer and salaried employee. It is not necessary that every entity in a superclass may be a member of some subclass. So it means that an entity can just exist in the superclass and not be a member of the subclass. So we want to look at the attribute inheritance in superclass-subclass relationships. An entity that is a member of a subclass inherits all attributes of the entity as a member of the superclass. It also inherits all relationships. What we mean by this, look at an example of student as a superclass. We have said that a student can be a part-time student or a full-time student. When you look at the generalization of the subclass student, part-time student, and full-time student, they are all students. So in general, all students must have an admission number or a registration number if you want, must have a name, they must have enrolled for a course, they must have a gender, they must have a date of birth. Those are attributes that are general to all students. Whether this student is full-time or part-time, this student must have those particular attributes. So when you go to the subclass, when you're talking about a part-time student must inherit all the attributes of the superclass. But in addition, a subclass, what differentiates a subclass from another subclass is the fact that a subclass normally has a subclass-specific attributes. Subclass-specific attributes. For example, in our case, when we talk about part-time student, we want to know what units this student has registered for. Because the number of units registered for determines the amount of fee that the student will pay, because we are assuming that in this case, the fee to be paid is determined by the number of units taken. So that is now, those are attributes that differentiate that particular subclass from the full-time student subclass. So the set specialization is the process of defining a set of subclasses of a superclass. So the set of superclasses of subclasses is based upon some distinguishing characteristics of the entities in the superclass. So an example, secretary, engineer, technician is a specialization of employee based upon the job type. So the job type is what differentiates the secretary from the engineer. And an engineer is actually different from a technician. So they may have several specializations. We may have several specializations of the same superclass. Let's look at another example here. Another specialization of employee based on method of pay is salaried employee or hourly employee. In this particular case, we are assuming that the superclass is employee. So the superclass is employee. And from the superclass employee, we have two types of employees. We have salaried employee, or what we can call full-time employee. And we could also have hourly employees. And so employee is the generalization, is the general class, is the superclass. But then we have some subclasses here, and the subclasses that we are having here are actually two: salaried employee and hourly employee. These two employees are different in nature. What makes them different? a salaried employee would have a grade, and they are not paid based on the number of hours worked. Whereas in this particular scenario, an hourly employee or a part-time employee is paid based on the number of hours worked. So if we are to go into the specific attributes that differentiate or distinguish these two as subclasses, we can say the grade, the job group, or the grade is what differentiates the salaried employee from the hourly employee. The hourly employee will have one very unique attribute that is not present in the salaried employee attribute: the hourly rate and the number of hours worked, because those are things that will be used in calculating their pay. So superclass-subclass relationships and generalization can be diagrammatically represented in ER diagrams. So attributes of a subclass are called specific attributes. For example, the typing speed for the secretary. In the example that we had in the earlier slide, we had a subclass called secretary as an employee. What would distinguish the secretary from the engineer? There is a subclass specific attribute, and that is for secretary, it is the typing speed. The engineer, under the engineer, we would not have the typing speed as an attribute of the engineer subclass. So attributes of a subclass are called specific attributes. For example, the typing speed of a secretary. The other thing that we need to note is that the subclass can participate in specific relationship types. For example, belongs to, of, hourly employee, belongs to. So we'll be able to look at the participation in relationships as we move forward. The notation that you'll be using in drawing our enhanced entity relationship diagrams is what we call the Shen notation, the Shen notations. And I want you to note that there are various notations that can be used. There are various notations that can be used in drawing enhanced or general entity relationship diagrams. But the notation that we are going to use, and that is what is also used in our core textbook, Database Systems by Connolly and Begg, is what we call the Shen, C-H-E-N notation. Now, this is an example of a specialization. In this case, we have employee as the superclass. The employee that we have in our superclass also has some general attributes. The name, we have serial number, we have the birth date, we have the address, and we have the job type. These are general attributes. Then we have some subclasses. This is how we show or denote that these are now subclasses of the employee, the subclasses of the employee superclass. In this case, we have the secretary, we have the technician, and we have the engineer. And you'll be able to see that the secretary, these are specific attributes that distinguishes this subclass from the technician subclass. What distinguishes these two? The secretary has typing speed. typing speed as a subclass specific attribute. And then we have the technician grade, because the technicians would have different grades and would like to store that in a database. So we have a specific attribute that stores the grade of a technician. Then the other thing that we'd like to store for the subclass engineer is the engineer type. The engineer type. Now, does it mean that these subclasses will only have these attributes? No. We said that all the subclasses normally inherit. They normally inherit all the attributes of the superclass. So in this case, the superclass is the name. It has the attributes name, SSN, birth date, address, and the job type. Let's look further at generalization. The reverse of the specialization process is what we call generalization. You realize that specialization is going from up down. It's from up down. But then when we look at the generalization, generalization is doing the opposite of what we had in specialization. So several classes with common features are generalized into a superclass. Original classes become its subclasses. So for example, let's look at this. We have a car, truck. What are these? If you were to be told there is a car, there is a truck, and then you are told to give a general name for this, you would say that they are vehicles. So both the car and the truck, they become subclasses of the superclass vehicle because you have grouped them together and given them a general name. So we can view car, truck as a specialization of the vehicle. So in this case, the vehicle is the superclass. Alternatively, we can view vehicle as a generalization of the car and the truck. And if you think about this going further, you would think that you would actually assign the car and the truck some subclass specific attributes like we have done to the employee superclass in the previous example. So let's look at data modeling with specialization and generalization. A superclass or subclass represents a set of entities. So these are shown in rectangles. Actually, all notations use rectangle to represent an entity. And they are shown in rectangles. So sometimes all entity sets are simply called classes, whether they are entity types, superclasses, or subclasses. Sometimes they can be generally called classes. I want us to take this further by looking at constraints on specialization and generalization. And these constraints should actually appear. They should appear on your enhanced entity relationship diagram. Remember, as a database designer, you first sketch it down on paper before it can be implemented physically. And just to remind us a bit, you know that we have 3 stages in developing a database. There is the conceptual level, there is the logical design, and then we have the physical design. So this is still at the conceptual design level. It's still at the conceptual design level. This is actually what is done last before you go to the logical design, because the next thing we are going to do is to still see how we can do a logical design from this. So two conditions apply to our specialization stroke generalization. What are these two conditions? We have the disjointness constraint. The disjointness constraint. It specifies that the subclasses of the specialization must be disjointed. They must be disjointed. An entity can be a member of at most one of the subclasses of the specialization. And I'm going to explain that in the next slide using an example. This is specified by using a D. There is a small d, not a capital D. A small d when you're drawing your enhanced entity relationship diagram. If not disjointed, overlap, that is the same entity may be a member of more than one subclass of the specialization, and this is specified by an O in the EER diagram. So remember, there are two symbols that we are using in this case. We are using an O and we are using a D. An O is being used to denote an overlap. An overlap. A D is being used in denoting a disjoint. A disjoint. There is also what we call a completeness constraint. Completeness constraint. The total specifies that every entity in the subclass, in the superclass, must be a member of some subclass in the specialization stroke generalization. Let me repeat this. Total specifies that every entity in the superclass must be a member of some subclass in the specialization stroke generalization. So, shown in EER diagrams by a double line. So, for a total, we will use double lines. We will use double lines to denote a total. Then partial allows an entity not to belong to any of the subclasses. Partial. Partial is a single line. Total or mandatory is we use a double line. So shown in ER diagrams by a single line. So let us look at that now. Hence, we have four types of specialization stroke generalization. We have what we call the disjoint total and disjoint partial. This is how we show it on our enhanced entity relationship diagram. So we will have, let me start with the total. The total. The total, we are having the double lines here. The superclass is on top. So like in our example, we could have the employee here on top. Then we could have the part-time employee or a part-time full-time employee and hourly or part-time employee. So these are now the subclasses. These are the subclasses. This is the superclass. And then we have the double lines. We have the double lines. The D is inside that circle. The D is inside that circle, which means it's a disjoint It is a disjoint. A disjoint, mandatory. Disjoint, mandatory. Mandatory because we have two lines. We will see examples of each of these scenarios. The other one is the disjoint partial. Disjoint partial. For disjoint partial, it's the same scenario, and then we have the D in the middle over there. Then apart from the D, we have a single line. A single line is what tells us that it is partial. The D is disjoint. The double lines for the one below here is mandatory. So this is disjoint partial, and this is disjoint total, and this can also be referred to as disjoint mandatory. I want us to look at examples of those two scenarios, disjoint total and disjoint partial. I want us to look at those examples here. In a department, in a university, a department can either be academic or administrative. This normally depends on the business rules. What I'm saying here, it doesn't mean that it applies always. It depends on the scenario that you are modeling, because a database is designed to capture data for an organization, and each organization has its own ways of doing things, and they have what we call their business rules. So you must take into consideration the business rules of that particular organization that you are developing a database for. So let us assume in our case here, a department at Mount Kenya University can either be academic or administrative. What that means is a department cannot, say the library department as an example, library. The library cannot be the same one that is also teaching students on how to become librarians. The library is administrative. They do not teach. They do not have students in that particular department that we are calling the library. The hostel department is administrative. They want to admit students into the hostel. They want to look after their well-being. At any time, if they are asked how many students are in the hostels, they can be able to say, they can be able to collect hostel fees, and they do not really deal with any academic issues of students in that particular hostel. So in that case, we also have academic department, like the students who are taking this unit some belong to the IT department, and some belong to the enterprise computing department. The departments are academic. They are academic. They are dealing with their studies. They want to know whether the students have taken their exams, whether they have registered for units, because they are an academic. The IT department is academic. The Department of Enterprise Computing is an academic department. So what it means here, when we put two lines here, it means that it is a must. It is a must because it is total. It is a must that any department that we are talking about here must either be an academic department or an administrative department, but cannot be both. It cannot be both. A department cannot be both academic and administrative at the same time. Why? Because we have a D. A D here denotes disjoint, which means an entity instance cannot participate in both of these subclass instances must belong to one of these subclasses. So when you talk about the hostel, it's either academic or administrative, not both. Security department cannot be both academic and administrative as far as our business rules are concerned. So going back to disjoint total, it means that a department must belong, not may belong, no, must belong to one of these two. Must belong to one of these two. Must be either academic or administrative. Let us go to the next specialization, and it's called the partial. The partial. The partial here is denoted using a single line. If you look at this diagram here, you will be able to see that it has a single line. The previous one had two lines. So the single line in this case means partial. It means partial. So partial, it means that an employee can just be an employee and the subclasses here, the ones that we already have here are three. We have secretary, analyst, and engineer. But this lack of the two lines takes care of a scenario where an employee is not a secretary, analyst, or an engineer. So if you bring another employee, maybe he's in the security department, for example, would fit as an employee. Because that employee does not fit in any of these. Does not fit in any of these. But what we saw in the previous one, the disjoint total, must belong to one of these. One of the subclasses that we have must belong. But in this case, it is not a must for an entity instance to belong to any of these. Can just belong to the superclass and not participate in the subclass entity types. I hope that is clear. So we also have constraints on specialization and generalization. These are continuation, and we want to now look at the overlaps. Overlapping. Remember in the previous one, we were using a D. In this case, our notation will be an O. Where we have the superclass. This one is for overlapping partial because the line is one. It's a single line. Single line, as we have said, denotes partial. Double line means total. So single line is partial. The O means overlapping. So in this case, it's overlapping partial. Overlapping partial. The next one is overlapping total. Overlapping total. Overlapping total. Because we have a double line. I want us to look at an example of where these two apply. We have parts. We have parts here. We have parts. And let's say these parts belong to an industry that does manufacturing and assembly. This part. So the case that we are modeling in this case is a manufacturing company. Some of the parts that they use for their manufacturing, they manufacture those parts themselves. They manufacture those parts themselves. But there are some other parts that they purchase. So they manufacture, there are parts that they manufacture, but there are some parts that they purchase from other manufacturers. So when you are referring to a part, because their database will have very many parts and it will be fed, a lot of parts will be keyed into their database. So their parts must either be manufactured, as in they have manufactured those parts themselves internally, or the parts that you have in their database might be purchased. For example, the companies that manufacture computers like IBM, like Dell, in as much as they manufacture many parts, there are parts that they do not manufacture, but they purchase. For example, the processors. We have heard that we have Intel processors, and we know there are other processors. So if we are talking about a company that manufactures parts, that manufactures computers like Dell, some of the parts that they have, they manufacture themselves, but there are other parts that they do not manufacture, like the processors, they purchase them. So if you are creating a database for that, you would depict them as such. So it means that any part in this particular database is either manufactured or purchased. And it cannot just be a part. It must belong to one or more of these subclasses. Let me now bring in the concept of the O, because you would wonder what makes this different from the one that we had in the disjoint mandatory. What makes this different is the fact that a part can be both manufactured and purchased. Let's use an example of a system unit. A system unit, in as much as they are manufacturing most of the parts inside that system unit, there are some parts that are purchased, like the processor. So if you are to be asked the system unit, which subclass it belongs to, it doesn't purely belong to the manufactured part. Neither would it belong to a purchased part. It would belong to both, because it has components that are both manufactured and components that are purchased. There are components that are manufactured and there are purchased components. So it has both. And that is where now the O is coming in. That is where the O is coming in, because some parts might be both manufactured and purchased, or might comprise of components that are manufactured as well as purchased. So let us go to the last scenario, and this scenario is an example of an overlapping partial. It's an overlapping partial specialization. Overlapping partial. So here we have an O and then a single line. We have an O and then a single line, which means it is partial. It is partial. Now, this scenario, we have an artist. We have an artist. And as you know, there are many types of artists. We have different types of art. So in our database, we decide to make a provision for a singer or musician. And then we have actor. Singer and actor. Those are the two subclasses that we have provided for in this particular database. Now, what if we, and when we have the O, it means that a singer can also be an actor, because a singer could also have a talent in acting. So it means they would participate, and you would have a scenario where one individual participates in more than one of these subclasses. One individual participates in more than one of these subclasses. So we could have a singer who is just a singer and he doesn't do any acting. But we could have a scenario where a singer also does some acting because he's also interested in acting. And because we have this O is what allows us to have a subclass participating in more than one of these subclasses instance. We also have a single line. Single line means that it is not a must that a singer, that an artist be a singer or an actor. There are other types of art that may not have been captured in this particular case. For example, there are people who are talented in drawing. That is also an art. So if you have such a scenario in the database and you do not have a subclass that accommodates that particular type of an artist, that would still fit as an artist, just an artist, because there are many other arts that we may not be able to depict here. So when you have an overlapping partial, we'll take care of that particular scenario. So we have an example here. I would like us to have a look at an example so that we can fully understand the concept of enhanced entity relationship diagrams. A marketing company has several branches located throughout the country. Each branch has several marketing employees, one of whom is employed as the branch manager. Each branch is responsible for a group of contracted marketing projects, and any number of the employees, possibly in different branches, may work on a contracted marketing project. It is also likely that an employee could be working on many contracted marketing projects at a time, and indeed could work on the same contracted marketing project at different points during the project's lifetime, which could span several months. A contracted marketing project will involve the development of one or more marketing events, which currently relate to one of 4 media alternatives. And currently we have radio, we have newspaper, or the internet. It is likely that the number of media alternatives will increase over time as new media channels emerge, e.g. interactive TV, Wi-Fi, and others. So I want us to first start by identifying where our entities are. I have already identified the entities for you. Marketing company has several branches. I see sometimes students identifying the marketing company as an entity, and that is wrong, because if you are developing a database for Mount Kenya University is not an entity, because an entity is anything real or abstract about which you can store data on. So in that case, we are interested in the branches. We are interested in the branches because we want to keep data of on the various branches throughout the country. And then marketing employee. The employee is an entity. And we can see one is employed as the branch manager. The manager is also a kind of an employee. A manager is an employee. I've highlighted that because we need to think about this in terms of superclass, subclass, or generalization, specialization perspective. Each branch is responsible for a group of contracted marketing projects. So we'd like to keep data about marketing projects. And we are told working on many contracted projects, and this on the marketing projects. Then in this paragraph, we have marketing event. This marketing event is also important to us because we want to know the various marketing events that we have. And we want to keep data on the marketing events, where they were held, what was the budget, and all that information. Then we have the media alternatives. From the various media alternatives, we would like to get information on the media alternatives. And in the future, we can be able to tell that this media alternative was better, it was more impactful. We got better results from that marketing or from that media alternative. So I have highlighted for you the various entities that we have, and I want us to draw this enhanced entity relationship diagram. So branch is an entity. Branch is an entity, and branch has employee. Now we want to see, and you already know this is how we depict the relationship type. And in share notation, we can also put the multiplicity, or what we call the cardinality of a relationship. So for this one, a branch can have many employees. Many employees. Many employees. But you cannot have, and it means many employees can work in a branch, but you cannot have a branch, or you cannot have different employees one employee belonging to many branches. An employee cannot belong to many branches. So this is what the one to means many relationship here means. So has employee. I want us to look at the type, employee type. And this will be the subclass, superclass relationship here. Because we do not know could be other employees, could be maybe a marketing employee or a marketer. Other employee could be a marketer, manager, marketer. So in this case, an employee cannot just be an employee. Let's say that an employee has to be either a manager or a marketer, and you can even, if we know of other instances or other types of employees that we have in this scenario, we can just put a link there and write that down for it to become a disjoint mandatory. It means that what we'll be depicting here is that an employee has to belong to one of the subclasses that we have over there. Then we are told that each branch is responsible for contracted marketing project. So marketing project is an entity. And as you think of an entity, and sorry, I forgot this, need to have that so that we show that these are subclasses of this particular superclass. So a branch has, or from what we can see, is that each branch is responsible for a group of contracted marketing projects. We can say responsible for. Now, I will not complete this diagram today, but I want you to look at the other part of this particular case study and complete that diagram. The branch, we are told, let me just do the cardinality for you. Each branch is responsible for a group of contracted marketing projects. So one branch will be responsible for many marketing projects. So it's a one-to-many relationship. And just to remind us as we come to the end of this is that we have one-to-one relationship, we have one-to-many relationship, and then we have many-to-many relationships. For many-to-many relationship, it is good to note and very important for you to note that a many-to-many relationship is not implementable in a database. A many-to-many relationship is not implementable in a database. So it has to be resolved. You have to resolve the many-to-many relationship so that you end up with a one-to-many relationship, one-to-many, and in the middle, you have to introduce a new table, which we call a link table, a linker table, to help you dissolve that particular relationship or break it down from the many to many so that you can now be able to implement it in a database. So we have looked at superclass, subclass, hierarchy, or specialization and generalization. And under that, we have looked at disjoint mandatory. This disjoint mandatory. Then we have disjoint partial, where we have one line. And then we have overlapping mandatory, where we had the O in the middle. Overlapping mandatory would look like this, but then with an O, and then overlapping partial. Overlapping partial has an O and then a single line. And for today, we have come to the end of lesson 1. And thank you for staying with me. See you next time.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.